Hello guys, this is the project which I have developed basically, which is called JusticeGPT, the IPC legal chatbot. IPC corresponds to the Indian Penal Code, and you basically have this interface with this tag on top of it with the menu bar. Basically, it just is a chatbot, and it's a multi-agentic RAG chatbot. Retrieval augmentation generation, when we say uh, that it basically answers the queries based on the context which we have provided, and it's also multi-agentic in the terms that it uses basically two agents, one for the FIS retrieval. FIS is a vector store here which we have used, and the other one is the chroma based vector store. Uh, Two agents corresponding to two different databases, since we could have a large corpus of data which could be very well divided, and we could take away the benefits of both the architectures, both the SQLite based Miss Chroma as well as the FIS indexes, right? So we can fine tune and we can take the advantages of both the architectures here. So using the multi-agentic approach, and you finally have the one more agent, which is the synthesizer, which will give us the synthesized response on the query which we have asked basically. Let me show you a quick demo and what is happening behind the scenes. So I could very well say that what is section I don't know 308 of IPC, and it what it does, it triggers a lang graph basically, and the graph comprises of the agents executing in sequence. So as you can see, the two agents have executed, and on the first run we will have the let's say the creation of the documents. The documents would be crawled from the web, and it would be stored into the stores by chunking it into the various embeddings. So once the embeddings are created, basically we'll be storing it in the vector stores, and the chromas and the files, and we'll be building two different indexes, you can say, and we will also have a shared memory, so that the context across the chatbot is maintained, and we could ask further questions on the same query which we have asked. So for example, here, what is section 308 of IPC? So it talks about section 308 is attempt to commit culpable homicide, etc. So we could ask it further question like what okay let's does it is it bailable? So here the idea is that since we have the memory integrated, um, the conversation buffer is maintained, and since we have the conversation buffer maintained, it would know from it that it refers to section 308, and then it will answer whether it's bailable or not. That's the idea behind it, and this is also done through the agent which is being shared through the memory which is being shared uh, across the two agents, since they are referring to the corpus of documents, one large corpus of documents divided into two basically. The memory also has to be maintained across the agent. So what would happen is that there would be a condensing agent which condenses the previous responses and requests, and it basically generates kind of a memory, a kind of a history, so that the next questions which you ask is takes into consideration the history as well. So for example, here I have asked is it bailable? So it takes into consideration the previous question and the answer, which is what is section 308, and the answer which I got from the chatbot, and then it generates the final response, and it says that the offense under section 308 is non-bailable. So it recognizes that I am talking about 308, and so on and so forth. Basically we can ask what is section 420 of IPC. So here I'm asking another section, and it would now change the context obviously, and it would tell me about what is section 420 based on the document which I have provided. So by the time it does that, I would quickly give you a walkthrough of the code, and The real magic is happening at the graph level, where we build the condense agent followed by the agent 1, agent 2, and synthesizer. So these are basically acting in sequence, and you can see the edges from condenser node to the agent 1, then agent 1 to agent 2, and agent 2 to obviously the synthesizer, which will take into consideration the responses from agent 1 and agent 2 and generate the final condensed response. It would act as a senior lawyer, and it will give us the, let's say, the answer about it. So what each agent does is, we can go ahead and we can see, so the condenser basically creates a standalone query from the previous context which we have really asked. So it takes into consideration the history as well as the question which we are asking, the follow-up question, the current question, and it combines with that history and it generates a prompt. And the prompt has been provided in the prompt .txt. So all the prompts are here, and we are storing it with certain keys like synth or condense, etc. And for example, here we are using the condense keyword, so we are getting this query, and the history which we have seen is passed over into uh, this parameter, and similarly the follow-up question, the current question, is passed into this parameter, and then we get a final standalone question. That final standalone question is the entry point for the graph, and that question comprises of the history and all the data. So now the agents receive the conversational history, and with that history basically we can do a invocation of the rags. So for example, the agent one here is a retriever which has been built. So it's a retriever on the ChromaDB. Agent 2 is a retriever on the FireDB, and we are storing the corpus of documents divided by 2, right? So we are storing it into two separate databases so that we can use and utilize both the technologies here through the multi-agentic framework, right? So we do pass the shared memory which we have created, and uh, this shared memory is used to basically retrieve the documents from the QA chain based on the context, based on the standalone query which we are passing. So that's the idea behind it. Basically, we maintain the conversation history through the history agent, and then we have the memory which is being supplied as arguments to the two agents, and they were nothing but the normal retrievers. And those retrievers basically operate in sequence, and the response is stored back. If you see the agent one execution, for example, this is the agent, and the result of it is stored back into the state variable of a graph, which is answer 1, and similarly the answer 2 is stored into the state variable of the graph, which is answer 2 here, the keyword. So both the answers are provided to the synthesizer agent, and we get the prompt for synth here. And for example, synth is the keyword here, so we will be getting the prompt which is corresponding to this. So we have just written a normal basically lookup into the text file, and we get it based on the keyword. So synth will give us this keyword, and we have a follow, let's say a fallback query, but we do have the query inside the synth. So it will give us, you are a senior lawyer and legal writing expert, merge the two draft answers below. So answer 1 and answer 2 is going into these placeholders, and then we are expecting a final answer. So we both are going to unify them smoothly, return only the final answer text without preambles. So that's the idea behind it, utilizing the two corpus, the two agents, utilizing both the technologies, powered by memory. So it becomes altogether a powerful multi-agentic RAG, and very well this can be extended to even include remediation for the various IPC sections. But right now we are providing the corpus, which consists of the information about the uh, various IPC section. So if I open the document which I have downloaded over the internet, it comprises of the various IPC sections. So it has around 200 pages. So you can see the various IPC sections, but it does not really provide remediations for it, the legal remediations. It's more of the, right now it's more of the let's say the complete information. It's like a lawyer which gives you complete information of the what are the sections which could be invoked, and what are those sections comprising of, which additional sections could be invoked, etc., and which the crime falls under which category. So those things. So it's a legal bot which is really useful, especially if you are looking for quick answers to your legal queries, and you need to have a context when you are going and actually approaching a senior lawyer, or you're a lawyer and you need some information about certain sections because you will not have it right over your mind. So in both the cases, for the client as well as the lawyers, this is quite useful, and anybody who is involved in legal matters would really find this extremely useful. And this could be very well extended, and we could create numerous branches across this application, and we could add remediations agents, and we can add various enhanced operations. But I think this is right now in a very good state, so that it could be deployed into the production. So this is what I wanted to talk about, and it really covers about the multi-agentic aspects of it. And the UI we have prepared is basically using Flask. We just have an index, and we have the conversational buffer around it. And yes, this is the multi-agentic RAG architecture along with the memory, which is really useful, and which really hammers in the points of like agent to agent protocols, etc., which are really coming into a large scale right now. So all in all, this is a perfect application if you really want to explore the Indian penal code based legal queries, or you have some clients approaching you with certain certain regarding certain crimes or certain reports. You could very well approach this bot and get additional information and refresh your memory, or seek advices from it, right? So this is what I really wanted to showcase, and I hope you find this pretty amazing too. So thank you for listening to me. Hello guys, so this is the project which I have developed basically, which is called JusticeGPT, the IPC legal chatbot. So it